See the question. Prove that the curves x is equal to y square and the another curve xy equal to k cut at right angles. Condition is if 8k square equal to 1. Okay, that means if 8k square equal to 1, then these two curves are cut at right angles. First, see the meaning of curves cut at right angles. Okay, here I'm considering one curve. Okay, and I will name it as x is equal to y square. This is our first curve. Okay, consider the another curve, that is xy equal to k. Then see, given data is curves cut at right angles. Here in this point you can observe two curves are intersects. Okay, this is the cutting point for these two curves. Okay, I'm taking it as P of A comma B be the cutting points of these two curves. Draw tangent to x equal to y square. Okay, in this direction, see, I'm drawing tangent. This is for x equal to y square. I'm taking it as L1. Okay, then see, one more curve is there, right? Xy equal to k. Again, I'm drawing tangent to that curve in the same point P of AB. Okay, now see, here I'm taking L2. Then here you can observe 90 degree, right? Or here you can see 90 degree. That's the meaning of two curves intersect at 90 degree. So meaning of curves cut at right angles means if you draw tangent to that two curves at the point of intersection, then angle made by the tangents equal to 90 degree. Clear? Now see the given curves. One curve is x is equal to y square. Another curve is xy is equal to k. These two curves, observe, point P of A comma B is lies on these two curves, right? Then in straight line chapter you studied, right? Whenever point lie on a curves, their coordinates satisfies the equation. Okay, this is a very important condition. That means if you substitute coordinate of this point, you will get right hand side equal to left hand side. Okay, here I'm substituting. First equation will get a is equal to b square, take it as equation 1. Second equation, see, xy equal to k is there. X in place of x ordinate, that is a. In place of y ordinate, b is there. You need to substitute ab is equal to k. This is a second equation. It's a very important step for problem solving. Just remember, here see, x equal to y square, one curve. This is the tangent L1. Another curve xy equal to k. Here see, you can observe intersecting point, right? I'm drawing one tangent, again another tangent at that point P. If that two tangents intersects, then angle made by that two tangent equal to 90 degree. Actually, we need to prove the result as if 8k square equal to 1, then curves cut at right angles. For our easiness, I will prove the result in reverse method. That is, I am assuming that assume curves cut at right angles. Okay, just assuming the reverse way. Okay, this implies, see the tangents, that two tangents are perpendicular to each other. Tangents are nothing but two straight lines, right? Suppose, see, here one straight line is there, again one straight line is there. If they cut at 90 degree, okay, we say that two lines are perpendicular to each other. In your first VUC straight line chapter you studied, right? Two lines are parallel, that implies m1 equal to m2. Slope of the first line equal to slope of the second line. Two lines are perpendicular, that implies m1 into m2 equal to -1. Product of their slopes equal to -1. This is a condition. Whenever two lines are perpendicular to each other, product of their slopes equal to -1. Here you are assuming curves cut at right angles. That implies their tangents are perpendicular to each other. I'm taking m1 as slope of the first tangent, m2 as slope of the second tangent, then m1 into m2 is equal to -1. Okay, for x equal to y square, this tangent I'm taking slope equal to m1. and xy equal to k, this tangent L2 is there, right? Taking their slope is equal to M2. So slope of line L1, that is tangent at P of A comma B at point P is equal to d by dx of the curve x equal to y square. Okay, this is the meaning of the slope, right? If you draw tangent, then slope is given by differentiation of the curve at that particular point. Clear? See, once again, you are calculating slope of the tangent L1 that is drawn to the curve x equal to y square. Then slope of this tangent at point P is given by differentiating the curve x equal to y square at the point P of A comma B. Okay, differentiate this one. Differentiation of x is equal to 1, and differentiation of y square is 2y into dy by dx. Okay, at A comma B. We want dy by dx, right? Dy by dx gives slope, right? So dy by dx is equal to 1 by 2y at the point A comma B. Okay, that is dy by dx is equal to 1 by 2 into, what is the value of y here? Y coordinate is equal to b, 1 by 2b. This is nothing but m1, right? Because you are assuming slope of the L1 is equal to m1. Similarly, slope of the tangent L2 is given by differentiation of the curve xy equal to k at the point A comma B. A comma B is nothing but P of point P of A comma B. Okay, now differentiate this one. Here see, product rule you need to apply. X into differentiation of y is dy by dx. Okay, plus y into differentiation of x is 1, because you are differentiating with respect to x, equal to, what is the differentiation of constant term? It's equal to 0. Okay, next step, see, x into dy by dx is equal to, shift y to right hand side, you will get minus y. So dy by dx is equal to, you will get minus y divided by x. Okay, just shifting x to the right hand side. Okay, you are calculating at the point A comma B. Here also at the point A comma B. So here substitute, this implies dy by dx, this is nothing but m2. Okay, slope of the second tangent L2, we denoted it as m2, right? M2 is equal to minus b divided by a, taking x ordinate equal to a and y ordinate is equal to b. So we have m1 equal to 1 by 2b and m2 is equal to minus b by a. Okay, we have the condition m1 into m2 is equal to minus 1. Substitute m1 and m2 value. This implies m1 is 1 by 2b into m2 is minus b by a is equal to minus 1. Then simplify, bb get cancels, here minus, this minus also get cancels, right? What you will get? This implies 1 by 2a, correct? 1 by 2 into a, minus minus get cancels, 1 by 2a is equal to 1. This implies a value is equal to 1 by 2. Okay, from equation 1, what is equation 1? Equation 1, we have a is equal to b square. This is our equation, right? Just check the previous equation. Then substitute, what you will get? 1 by 2 is equal to b square. This implies b is equal to 1 by root 2, taking positive root. Okay, actually you will get plus or minus, but I am taking here only positive root. B is equal to 1 by root 2. Now we have a and b values, right? A value is equal to 1 by 2 and b value is equal to 1 by root 2. So from equation 2, okay, what's the equation 2? We have AB is equal to K. What is A value? A value is 1 by 2 into 1 by root 2 is equal to K. In the next step, to prove the result, I am taking squaring on both sides. Okay, to get the result, you need to do this step, squaring on both sides. Okay, here you will get 1 by 2 into 1 by root 2 whole square is equal to k square. This implies 1 by 2 whole square is 1 by 4 into 1 by root 2 whole square is 1 by 2. Okay, you can square separately, right? AB whole square is nothing but a square into b square. So 1 by 2 whole square is 1 by 4. 1 by root 2 whole square, root and square get cancelled. So you will go to 1 by 2 is equal to k square. This implies 1 by 8 is equal to k square. Take 8 to right hand side. This implies 1 is equal to 8 square, or 8k square is equal to 1. This is the result. Okay, therefore result is proved. Okay, here we proved result in reverse way. Given question is curves cut at right angles only when 8k square equal to 1. We prove that result in reverse way. You are assuming that curves cut at right angles, then you are proving 8k square equal to 1. Result remains same.